Welcome to part 6 of this repair of this Bush VHF 64 radio, and yeah, part 6. It is taking quite a while. It is becoming a bit of a slog. It's actually been on the bench a few months now, so I do really get it finished. So at the end of the last video, I did change the discriminator. The reason I changed that was one of the slugs inside the transformer was jammed, and the spare at least was free on both of those slugs, so I can actually get the alignment done properly. I want to do that, and I'm going to do an RF alignment as well, because really getting to the bottom of the fault, I think it's going to be a process of elimination. So the adjustments, if I can do those and I'm satisfied with those, then there's a few less things to look at in terms of trying to get to the bottom of this radio. So let's see how we get on. So the radio's on its side again. I'm going to go through the FM alignment again. I did choose to replace the volume control potentiometer. In the end, I just wasn't happy with it, and it was causing me a few issues. So I'll swap that for a modern one. And also I have my RF signal generator that's arrived. It's just a basic one really, but I've actually checked it out. It's fairly accurate. Well, actually, it's very accurate for what it is. So it's going to do the job really nicely. There are actually a couple of issues with it. It does just drop the output at a certain point on the dial. It's only marginal. I'm sure I can fix that. It's probably an issue with the variable capacitor inside there. Other than that, that's working really well. It'll do the job very well for me. So yeah, I'm just going to crack on with this. I won't do the IF alignment on camera. I've done that before, but we will come back to it when we do the RF alignment. So I'll just come on to the RF alignment stage. So essentially what we need to do is get the RF signal generator set to 88 megacycles or 88 megahertz. Have the radio approximately tuned into that scale. What we can do, there's a little locking nut which adjusts the length of the cable which is attached to the cores going into the VHF box. And when we loosen that, we can adjust that, and we've got to make sure we get a peak on the meter there. The only problem we've got is there's not much travel left on that set of cores really. So I'm going to give it a go, and I can adjust it as best as I can really. So that's what I'll do now. I'll just loosen this off. Right, it's not fantastic in here. Oh, it's very tricky. Okay, we've done that. Let's just see if we can just adjust this. That's going down, and that's as much as I can get. It's a little bit better than what it was, so that's right at the end of the travel. So I'm going to actually just tighten that up. Okay, so for this next bit, I need to set the signal generator to 96 megahertz, which I have done, and I need to adjust the what we call L3, L4, which is just this can where the antenna is, and adjust that to get the maximum output. So I'll just give that a go. That's not really making any difference at all. Okay, that's tuned in there. Let's just see if we can make this I'm going to adjust higher. It's dropping down now. Yeah, so I'm going to do a little bit more research on that. It just seems a bit of an odd procedure, really, not complete, but let's get some responses there. But let me have a good restudy of that. I'm just reading the procedure verbatim. It just doesn't seem quite complete to me. I'm actually satisfied with the RF alignment in the way I've actually done it. So the first part of that process is adjusting the distance the ferrite cores travel within their respective transformers. That's why you adjust that chord. So that is L4 and L6, and that sets the minimum and maximum frequency range in the FM band, so around 88 up to 100. And the second part of the process, where you set the signal generator to 96 megahertz, really sets the amplitude. So that's the adjustment on cores L2 and L3, and that sets a peak for that band. So I've done that. So I'm satisfied with the way that's turned out. So I'll actually move on from the alignments now to do some further fault finding. Okie dokie, the radio still does not work in VHF mode after all that alignment. So I need a new strategy, and then my strategy now is to go and test the resistors. Now, I test resistors in these vintage radios in circuit, and the reason I can do that is that Ohm's law applies to help us. So let's say we've got a resistor, and it's a 1K resistor that's in circuit, and I apply a meter at these points, then a current will flow through that meter for that resistor. Just through the nature of electronics, there's going to be components connected around that, and there will be some path to current, DC current, around this circuit. Probably will be, not necessarily will be, but probably. And so there'll be a kind of a resistance here, and there'll be a resistance here. Now, I know from experience that these resistances Rx and Ry tend to be very high. If this was an inductor or a coil, then I would be reading 0 ohms across this 1K resistor. Now, in that scenario, I would actually snip one end of that 1K resistor and measure it out to circuit. But generally speaking, there's either no current path or there's a very high resistance to current there. So Ohm's law applies. So it'd be 1 over RT. That'd be the equivalent resistance of this system. 1 over 1K plus 1 over Rx plus 1 over Ry. So if Rx and Ry were quite large, then what I'd actually measure, if this was in specification, I might measure, say, 995 ohms. It'll always be less than 1K or slightly less than 1K. And if that's what I'm reading on the meter, I know that's okay. The way these old carbon resistors fail is they tend to drift high. You either burn out totally and come open circuit, which I can measure, or they drift high. So if I'm measuring 1.3K here, then this Ohm's law still applies. What I'll probably be reading on the meter is maybe 1.29K ohms. So immediately, if I get a high reading here that's more than 1K, I know there's probably something wrong with this resistance. So I would then actually just snip that end, verify the measurement, and then replace that resistor. In all these cases, from my experience, if I'm reading more than the example of 1K here in an outer tolerance way, then there's something wrong with that resistor. So I just verify that outer circuit and then replace them. And it usually drifts back in, or always drifts back into specification. When I put the new resistor in, I'll probably be getting something around that 995 ohms again. So that's why I'm confident of testing all these in circuit. So I'll record this a little bit by hand actually. It's easy to get around and show you what I'm doing. So I've changed the outer specification resistors on the audio transformer. There's one under there as well. And I do feel a lot better about the radio today. I think if I keep working through this way, we'll get to the root of the problem eventually. And what I've noticed, if we're looking here, there's I think it's a polystyrene capacitor, and it's in parallel with a 10k resistor. Something strange going on here because this resistor is reading short. What this circuit does, it bypasses the AC to ground, so the I guess the base of the antenna coil is held at a constant potential. That shouldn't read short. It's surrounded by capacitors, basically, so there should be DC blocking everywhere, so it should read 10k, effectively the outer circuit. It's reading short, so I need to find out what's going on there. So I'm going to snip this capacitor and just have a look, see what's going on, see if that bottoms out that particular issue. I do have another vintage capacitor of this type I can put in place if I need to change that. So yeah, I'm just going to do that and just keep working through the radio now, just focusing on the resistors. And I think if there's no forward movement then in terms of getting on top of the problem, then I'll go through the capacitors that are swapped, because sometimes I've noticed when you apply heat to them, they can melt a little bit and go out of specification. So I'm going to make sure that they're all okay as well. I'm sure we'll get to the bottom of this problem and get this radio working anyway. So you can see I've got this oscilloscope on the radio now. I cleaned up the valve sockets yesterday, and I actually put an earth wire on the device because I thought there was a lot of hum, and it really did improve things, especially on the AM. And in fact, the FM became a lot louder. I almost got to the point, do I just leave it here? But it was just one or two stations that were loud. Other ones were a little bit quiet. So I thought I'd get on with the task of going back and checking some of the capacitors that I replaced. And I haven't really done anything to the radio, just investigating really, and it just stopped working on the VHF. It's still very solid on the AM, but VHF has stopped, and I'm really confused as to what that might be. So what I thought I'd do, I'd drop an FM modulated 10.7 megahertz signal into the first IF stage, which is actually the ECH81 in FM mode, and monitor the output of that on the grid of the next stage. I'm getting a lot of attenuation. This is actually looking at the grid of the first EF89, which is the second IF stage. It's about 200 millivolts. The signal going in should be 600 millivolts, so 3 times that size. So I'm getting a lot of attenuation. When this signal goes into the third IF stage, I'm actually detecting a reasonable amount of gain again. I would have thought, no expert really, I would have thought there would have been amplification on the first IF stage. I would make sense rather than attenuation. So I think there's a problem there. I'm still not getting any audio out of this at all. I thought at least with an FM modulated signal, I'll be able to recover that audio tone. But I'm not getting stations through, and I'm not getting the sound through. And to me, this indicates a problem on that first IF stage. So I'll have a good look at what's going on there. Probably desolder most of the components, check them, and put them back. Hopefully, we might get on top of that problem. As it stands, though, like I say, I'm getting to the point where I'm just going to have to park this because it's just getting too frustrating. But we'll see how we get on with this. So I've gone about changing the outer tolerance resistors, 11 in total. Some of them were 50% high, most of them were about 30 to 40% high in terms of the maximum tolerance. and it hasn't improved the performance of the radio at all. It's still quite quiet, so that's a bit disappointing. However, those components definitely needed to be changed. I used 1 watt resistors, mainly because they're more in keeping with the radio chassis. So where am I now with the radio? I've actually recovered the FM to a volume that it was before. I went back and changed the first IF can just because I felt I was getting that attenuation. I know the can shouldn't be the cause of that attenuation, but I thought I need to do something. And I actually recovered the FM. I don't think that was a problem. I've got a gut feeling the problem why the FM went was, I believe, pin 2 and pin 3 of the first EF89 were very close together, so they may well have been shorting, which caused that drop in sound. Everything's okay now. I'm just back to where I was. So I do have a few ideas to go forward. I may be barking up the wrong tree with this attenuation between the first IF amplifier and the second IF amplifier. I shouldn't get an attenuation there in my mind anyway. So I'm going to get some advice on that and focus on that. I do want to take the radio off the bench, but not for very long. I've got a few ideas to proceed with, but there are other projects I can quickly get out of the way. So that's what I'm going to do now. I'll just bag this up for the moment, clear the bench down, and we'll get on with the next tasks. And then we'll pick up the radio again. So hopefully that'll be the final thing I need to do to it.